Robots are evolving, and with them, the tasks they can perform are getting more sophisticated. The challenge, however, isn't just in getting robots to do things quickly or with brute force. It's about teaching them the finesse required to manipulate objects with the same precision and control as human hands. DeepMind's latest developments in this area are leading the charge with two breakthrough AI systems, ALOHA Unleashed and DemoStart. These two systems are specifically designed to tackle one of robotics' most stubborn challenges, dexterity. Think about it. Tasks like tying shoelaces, placing delicate components into machines, or even folding clothes are second nature to us, but represent highly complex problems for a robot to solve. A robot not only needs to have the right hardware, but also the smarts to figure out how to apply just the right amount of pressure, angle, and timing. This is where AI comes into play, allowing robots to learn and adapt to these kinds of tasks. Let's start with ALOHA Unleashed, which takes robot dexterity to a whole new level, particularly when it comes to bimanual manipulation, using both arms together. This system is built on the ALOHA 2 platform, an open-source hardware system developed initially for simpler teleoperation tasks. But ALOHA Unleashed has taken this to a much more advanced stage, enabling robots to perform intricate tasks like tying shoelaces, hanging clothes, and even making fine-tuned repairs on other robots. Here's why that matters. Tasks like tying shoelaces involve a multitude of small, sequential steps that require both arms to move in perfect harmony. For a robot, this requires coordination between sensors, motors, and software, all while responding to real-time variables, like how the lace behaves as it's being tied. The system is able to do this by leveraging imitation learning, where a human operator initially demonstrates the task. The robot collects data from these demonstrations and then learns to perform the tasks on its own. One of the key advancements here is the use of what's called a diffusion method, which helps predict the robot's actions based on random noise, akin to how image generation AI works. The diffusion method smooths out the learning process, ensuring that the robot not only mimics the human, but adapts to variations in the task, like if the shoelace is slightly more or less taut than expected. This means the robot doesn't need to be micromanaged or shown thousands of examples to get it right. It learns from a few high-quality demonstrations and can execute the task with minimal additional input. The system's hardware has also evolved. The ergonomics of the robotic arms have been significantly improved, making them much more flexible and capable of precise movements. These updates are crucial when you consider the level of control needed for two-handed tasks like inserting a gear into a mechanism or hanging a shirt neatly on a rack. ALOHA Unleashed can even handle deformable objects, something robots have traditionally struggled with, making it particularly suited for tasks that involve cloth, rope, or any other flexible material. While ALOHA Unleashed focuses on two-arm coordination, DemoStart tackles a different beast altogether: multi-fingered robotic hands. Imagine trying to teach a robot to manipulate objects using multiple fingers with the same dexterity as a human hand. That's where DemoStart shines. This system uses reinforcement learning in simulations to help robots acquire the kind of finger dexterity needed for tasks like reorienting objects, tightening screws, or plugging cables into sockets. Training these multi-fingered systems in the real world would be incredibly slow and expensive. Each finger joint needs to move with perfect timing and precision, and mistakes in real-world experiments could lead to broken equipment or wasted resources. Instead, DemoStart trains robots in highly detailed simulations, allowing them to practice thousands of times in a fraction of the time it would take in the physical world. Once the robot has learned the task in simulation, its skills can be transferred to real-world applications with impressive results. The system uses an auto-curriculum learning strategy. This means it doesn't throw the robot into the most challenging tasks right away. Instead, it starts with simpler tasks and gradually increases the complexity as the robot improves. This progressive learning approach is highly efficient, requiring far fewer training demonstrations compared to conventional methods. In fact, it cuts down on the number of demonstrations by a factor of 100, allowing robots to learn from just a handful of examples while still achieving extremely high success rates. One of the standout features of DemoStart is its ability to handle multi-fingered tasks with near-human precision. In simulated environments, the system has achieved over 98% success rates in tasks like reorienting colored cubes, tightening nuts and bolts, and organizing tools. Once transferred to the real world, these robots maintained high success rates. 97% in cube reorientation, and 64% in tasks requiring more complex finger coordination like plug socket insertion. To make these simulations as realistic as possible, DemoStart relies on domain randomization. This technique introduces variations in the training environment, such as changing the lighting, object positions, and even physical properties like friction. By exposing the robot to a wide range of potential scenarios in simulation, it becomes much better at handling real-world variations. For example, a robot trained to insert a plug into a socket will encounter different types of plugs, sockets, and angles in simulation, making it more adaptable when it encounters these variations in real life. The physics simulator MuJoCo plays a pivotal role in DemoStart's training process, allowing for accurate modeling of real-world physics. Combined with reinforcement learning techniques, this enables DemoStart to bridge the sim-to-real gap, meaning that what the robot learns in a virtual environment can be applied in the physical world with minimal retraining. This near-zero-shot transfer is a massive leap forward, drastically reducing the time and cost needed to deploy these robots in real-world settings. These advancements aren't just theoretical, they have real-world implications that extend across multiple industries. Robots that can handle highly dexterous tasks will be transformative in manufacturing, healthcare, and even at home. In manufacturing, the ability to perform tasks like gear insertion, bolt tightening, and flexible object manipulation can streamline assembly lines and reduce errors. These tasks often require human workers due to their complexity, but with ALOHA Unleashed and DemoStart, robots are now capable of stepping in, increasing efficiency, and freeing up human workers for higher-level tasks. In healthcare, the potential is equally exciting. Consider a scenario where robots assist surgeons by handing over tools or even performing some parts of the procedure themselves. The precision required in surgical environments is enormous, and these AI-driven robots are getting closer to being capable of such tasks. Even outside the operating room, robots could assist in physical therapy, helping patients regain movement by performing repetitive, precise actions. In homes, robots with this level of dexterity could finally take on tasks like folding laundry, doing dishes, or organizing clutter. While we're not there yet, these systems are pushing robotics in that direction. But beyond these specific examples, what's clear is that we're on the cusp of a major shift in what robots can do. With advances in robot dexterity powered by AI, the limitations are falling away. Tasks that were once thought to be too complex or nuanced for machines are now becoming achievable. All right, the goal now is to scale these systems even further, enabling robots to handle more tasks and environments without needing task-specific training each time. Ideally, future robots will be able to switch between different tasks seamlessly, using one set of learned behaviors to tackle new challenges as they arise. Additionally, researchers are working on making these systems more reactive, allowing robots to adjust their actions in real time if something goes wrong. For example, if a shirt slips off a hanger mid-task, the robot should be able to recognize the issue and correct it on the fly, just like a human would. The journey is far from over, but the road ahead is exciting. With each breakthrough, robots are getting closer to becoming fully capable assistants, both in industry and at home. And while there's still work to be done to match human-level dexterity, we're moving steadily toward that future. Robotic dexterity powered by AI is no longer a distant goal. It's unfolding now, and it's poised to change how we interact with machines in our daily lives. If you're interested in more deep dives into AI, robotics, and the future of tech, make sure to like, subscribe, and leave a comment. Thanks for tuning in, and I'll catch you in the next one.